Hi, I'm back. So, I haven't made a video in quite a while, and this is because I have been busy doing my master's thesis. And tomorrow is my defense, so I've already turned my master's thesis in, and then tomorrow I have to do a presentation on for like 15 minutes and present all the research that I've done and the results that I've gathered, and I am super nervous. I am so nervous, and so I've been practicing my presentation, and I thought maybe it would be a good idea to record it, because that way I can time myself, and also I thought you would probably be interested in my master's thesis as well. So I want to try to record the presentation I've prepared now. Okay. Hello everyone, I would like to present today my master thesis on the topic of design optimization in early project stages, a generative design approach to project development. And my presentation is roughly structured in background, methodology, and if we have time we'll talk about verification, but most importantly the implementation and the experiment that I carried out, as well as the results and a discussion. So the problem that my thesis was based on is that in project development, as it is the initial phase of any potential construction project, we want to determine whether or not the project would be profitable. But at this point, no design exists yet. So all the calculations and studies that we carry out are based on estimates and past experience. So the question is it possible to automate parts of the design finding process so that we can provide reliable model-based data for project development? And this involves a design optimization that regards large aspects such as the position of the building on site, but also down to the smallest entity, that would in my case be a singular desk and its placement. So for a human it can be very hard to regard all these aspects at the same time, but with a computer we can look at a lot more design options a lot faster, and through multi-objective optimization we can be able to find well-performing design solutions. So how does it work? Its background lies in the natural principle of evolution. So through mutation we get different variations of genes, and then through natural selection those that don't perform well get ruled out, and this process repeats itself until we end up with a diverse set of very well adapted genes. And if we translate that to design, the individuals in a population are the different design solutions, and the genes, the chromosomes, are represented by the values of the properties of the model. So in a parametric model, the values for the parameters. So what we want to do is basically generate a bunch of different design solutions, evaluate them based on their performance, and then use the principles of evolution to optimize them and generate new solutions. And to imitate this process of evolution, a few different genetic algorithms have been developed in the past couple of decades. The ones that we use today work quite similarly. So a population is generated, then for each individuum the fitness is calculated, and then we use the evolutionary operators of selection, crossover and mutation to create a new generation. And what a genetic algorithm is supposed to do is preserve previously found good solutions, that is a principle called elitism, and progress to the true Pareto front as fast as possible which is the convergence rate, as well as, and this is especially important in design, provide a diverse set of solutions to the human decision maker so that the final solution can be selected by the human designer. And this is especially important in design because we are most of the time dealing with multi-objective optimization problems. That means we have multiple, often contradicting design goals or objectives. So how, in this case, how can we determine if one solution is better than another? And this is where the concept of non-domination comes in. That says one solution is better than the other if it is equal, or if it scores equal or higher in all of the objectives, but better in at least one of them. So if we look at this sketch here, we can see that we have two objectives, F1 and F2, and we want to minimize. So in this case, we can say C is dominated by both A and B because A and B score better in the design objectives. However, and A and B are not dominated by any other solution and therefore lie on the Pareto front. So, as I said, there are a few different genetic algorithms, but one that is very common is called the NSGA2, and it evaluates, and what's specific about it is that it evaluates the parents together with the children population, which ensures elitism, and then uses a fast sorting algorithm to divide the populations into subgroups, and uses the crowding distance comparison to prefer solutions that come from a less crowded region, so that preserves diversity of the solution. Now, to carry out a generative design study, we need three things. We need a parametric model that is able to explore the entire solution space. We need a set of design goals, and they're very important because they will determine what kind of outcome, what kind of results we will receive. And we need an optimization engine. So in this case, I chose the NSGA2 algorithm because it has proven to provide a very diverse set of solution, and it is implemented in the Dynamo plugin called Refinery. Now, as an example for my studies, I used the Siemens Construction Excellence, which is an architectural and technical standard for Siemens office buildings. Now, this is what a standard floor plan looks like, and we can see that it basically consists of three elements. The core units, which accommodate the stairs and the toilets. Then we have the office units where the actual desks are placed, and then the seam units where the fire escapes are. So the core unit and the seam unit are always the same, but for the office units there are 6 different configurations, from a very dense layout with 20 desks per unit to more looser setups of 12 desks per unit. Now, what we can say is that the width of the building is always fixed, but the length of the building is determined by how many of those units we line up. So to translate this into a parametric model, I work like this. So we start out with the project data, which is the same for all the solutions. So we need the outline of the site. In this case, I chose a current Siemens project in Hanover and the number of employees that work there. So in this case, it was we needed 500 workplaces. Then 2 variables, the start point and the orientation determine the largest inscribed rectangle, so essentially the area where we can grow the building. Now we check, is the rectangle fully within the site? And then we have two more variables, the number of units left and right, that we add onto the core. And then of course the last units on each side get turned into seam units. Now we can check, are all the units within this, the rectangle, and therefore they will be within the site. And then lastly, we have a variable called workplace density that determines how dense we pack the workplaces in the units, and therefore determines how many workplaces we have per floor. And then we need to replicate the floors until we have reached the 500 workplaces in total. So this is what this looks like in Dynamo. So we have here the variables, and when we start twitching one of them, so for example here increase the workplace density, and then we will need fewer floors to accommodate all workplaces. However, if we decrease the number of slices on one side, the building will rise again because it will need more floors to accommodate all workplaces. And what we can also see is that whenever we change one of the variables, the scoring in the objectives of the design changes as well. So what I did here manually, Refinery does automatically in the optimization. It is able to dock onto the variables and change them and observe the output. Now, if we have that parametric model, we need to talk about the design goals, so the objectives, the direction of the optimization. So together with Siemens, we chose 8 different design goals that are most important to them in the project development. So one would be, for example, we want to increase the comfort for the workplaces there. So this is measured by the rentable area that is available per workplace. On the other hand, we want to limit the energy that is consumed by the buildings. So we want to minimize the ratio of surface to volume. Or for example, to optimize the position of the building on site, we want to minimize the path from the outside of the site to the building entrance. So now, before we start the evolution, there's a few more parameters that we need to set. First, the population size, so it's the number of individuals that are in one generation. The number of generations, so how many iterations the genetic algorithm will run. The crossover probability, which is how often crossover will occur. And the mutation probability, which is how often we will have mutation. So for the population size, it's good to have bigger population size, because that means the chances are higher that a good solution is already part of the very first generation. However, if the population size becomes too big, it also takes very long to rule out bad performing solutions. So there's an ideal population size for every optimization problem. And in my case, I detected it at a population size of 120 members per population. And then I increased the number of generations until the average fitness of the population increased no further or very little, which was about after 50 generations. So I set the algorithm to work and received 14 results from the Pareto front with very different scorings in each design objective. So we can see the scoring here in this overview, and the decision maker will then be able to select solutions based on personal preference. So if they rather want to go with an decreased footprint or more rentable area, etc. So afterwards I carried out interviews with some project managers from Siemens to find out how happy they were with the process, and the feedback that I got was overall positive. So they see a high potential in generative design, especially because it prohibits the manipulation of design processes that are often manipulated by personal or internal political interests. And the decision, but with generative design, the hope is that the decision-making process would become objective and data-driven. However, there was also the wish for more objectives to be included, for example, the site topology, local code requirements, or the surrounding landscape and buildings. So, to conclude, I would say the most important thing in a generative design study is to have a clear concept of the design variables that you want to include and the objectives that you choose, because that will very much influence the quality of the results that you will get. Because there are essentially endless possibilities of what objectives to choose, and you have to consider what is most important to you. Is it really important to have a beautiful view from your desk, or is that something that is more nice to have but not a priority? Because it's easy to implement a lot of different factors, but it will also influence what kind of results you will get. Some other things, on the other hand, were very hard to teach the algorithm. So for example, for a human, it's very easy to place a rectangle within another shape, but in my study I had to spend a lot of time and effort into teaching the algorithm how to avoid invalid designs, so designs that are outside of the site. So how can we punish those solutions and teach the algorithm to rule them out as fast as possible. Also, throughout the study, I developed the opinion that the term generative design itself might be a bit misleading, because the computer does not generate a design. It doesn't have any inherent creativity. The human designer has to create an abstract vision, a concept of its design, and then the computer merely finds the best set of parameter values that optimize the design concept to goals that also the human defined. So therefore, I think the term generative design gives the computer a bit too much credit, so to say. However, I also have to say that setting up the algorithm and then letting the optimization run felt really liberating, because I knew that now my computer would work for me essentially for the next 5 hours, and there was nothing I could do with it during that time. And so I had some free time essentially. It took over a part of the work that I would have to do as a designer, so that felt very much Industry 4.0, where we have the computers take over boring parts or unpleasant parts of our work. And then after all, the process of choosing a final design becomes very transparent and data-based, because you have this very objective comparison of the different designs. And this was also reported by the interviewees from Siemens. So as an outlook, it would of course be important to also implement the other building shapes that exist in the Siemens Construction Excellence, and then implement the whole process into a BIM environment. So for example, to export from Revit the site outline into Dynamo, then run the optimization in Refinery, pick a favorite solution and export it from Dynamo directly with adaptive families into Revit and have the final solution as a BIM model automatically generated in Revit. Yes, so that would be how to turn it into an actual software product, for example. And then thank you for your attention, and that was it. I hope that was good enough. I had to go so fast over some of the things. 15 minutes is really not a lot of time for 6 months of research. But I mean, they have time to ask questions afterwards, so then I can explain some things in more detail maybe. Okay, so that leaves one last thing to do for tonight. And that is choose an outfit for tomorrow. So the first one is a very classic navy white combination with a blazer and a blouse. So this is what it would look like with the blazer on. I think I would have enough mobility to perform all kinds of movements. And this is what it would look like without the blazer if it's warm outside. I don't know, summer is already kind of over in Munich. But maybe we'll get one more nice day of sunshine tomorrow. And then the second option would be this black and cream combination of pants and blouse that I also sported at AU London. Let me know what look you think I should wear tomorrow. The most important thing is that I don't forget this here, which is the printed out versions of my actual thesis. So if you're interested in reading my thesis as well, you will probably be able to do so because it will be published on the university website, and I will make sure to share a link on like my Twitter or LinkedIn or wherever you follow me. So one more task to do tomorrow with the presentation, and then I will be done with university and ready for the job market. Very exciting times, very exciting. Good morning! Today's the day! I woke up this morning at 4 and couldn't go back to sleep because I was so nervous and my head was just like going through every slide over and over again. But I do feel ready now. I feel confident about it. I think I've prepared well, and after all it is my thesis, so when they ask questions, like, I will be able to answer them. I chose the second outfit because when I looked at the footage I saw that the first blouse was quite see-through, and also I think it will be warm enough today to go out without a jacket. Okay, so let's go!